Hello everyone, welcome to another video from the tutorial series Aspen Plus Mastery and Certification. My name is Tabish. Today we will learn how to add components in the Aspen Plus component list, learn about different component databanks, view pure component scalar and temperature dependent properties and parameters, and learn how to define a component that is not available in the Aspen Plus library. For the first three contents, we will follow this example where natural gas containing its constituents including methane, carbon dioxide, hydrogen sulfide, nitrogen, ethane, propane, isobutane, normal butane, isopentane, and normal pentane has to be processed to remove acid gases by a 38% water solution of diethanolamine. So you are asked to create the component list for the simulation of this process and view pure component properties and parameters. So in order to add the components in the component list and view their corresponding properties and parameters, let's jump into the Aspen Plus. Here is the window that appears when you open the Aspen Plus. Go to New tab. Either you can start a new simulation or you can start with any of the default template from the categories, for example, gas processing or a general category. So let's start a new simulation without the selection of any template. This is the window that appears in the properties environment. As you can notice in the bottom left corner, currently the properties environment is active, whereas the alternative environments are the simulation environment, safety analysis environment, and the energy analysis environment. In the navigation pane of the properties environment, you can notice the global settings in the setup option. In the component section, you can define the components. In the method section, you can define the thermophysical property method. To add the components in the component list, go to the component specifications. Under component ID, you can simply add the name of the component. For example, methane. If the component ID matches with the name of the component stored in the Aspen database, it will retrieve the component and corresponding information. You can also notice the component type retrieved from the databank. It is conventional. Alternatively, you can change the type of the component if desired so. The component name, alias, and the case number are also listed here. What are the databanks? Let's go to the enterprise database. Here you can notice in the left window all the available databanks are mentioned, whereas the selected databanks for the current simulation are listed in the right window. If you want to add another databank to the selection, you can simply move it to the right, or if you want to remove from the selection, you can move it to the left window. Another thing you should notice is the sequence of the databanks. The sequence of the selected databanks is very important for the Aspen Plus. If you want to change the sequence, for example, pure 40 should be at number 2, you can simply move it to the down or you can move it up. By default, these are the 6 databanks those are selected in the new simulation case. And the selection contains pure 40, aqueous databank, solid databank, inorganic, EOS, and the NIST TRC databank. So while searching the component information, Aspen Plus first looks for the first component that appears at the very top of the sequence. If the component information is not found in the first databank, Aspen Plus moves to the second databank, and so on. What exactly are these databanks? Just go to the Help button. In the content list, if you go to the Aspen Plus references, here the third section indicates a physical property data reference manual. Under the tab Databanks, you can view pure component databanks. The most common pure component databank is the Pure 40 that contains data from many sources including Dipper, Aspen PCT, API, and Aspen Technology. These are different sources that provide the information of the pure components, and all of those are stored in the databank Pure 40. Similarly, there are other databanks, for example, acid gas, that contains pure, binary, and pair parameters for the components and the methods used in the acid gas treating packages in Aspen HYSYS. Another very important pure component databank is aqueous, that contains pure component parameters for ionic and molecular species in the aqueous solution, and typically it is used for the electrolytic systems. There is another data bank named as biodiesel. Biodiesel contains pure component parameters for the components typically found in the biodiesel production process. And similarly, you can view other pure component databanks. As you can also notice, there are other databanks with the same pure name but with a different number. And these are the databanks in the previous Aspen Plus versions. These databanks have upward compatibility. For example, Aspen Plus version 10 has pure component databank named as pure 36. If you have any Aspen Plus file from the version 10, you can open it in version 14, and by default, the pure component database will be pure 36, and Aspen Plus will give you an option whether you want to keep the same information in the version 14 or you want to update the databank. So let's dig into further into the Pure 40 databank, what kind of information it contains. Pure 40 databank contains parameters for 2350 components and mostly are the organic components. And this databank contains universal constants, temperature and property of transition such as boiling point and triple point, reference state properties, coefficients, safety properties, functional group information for all the unified models, parameters for RKS and PR equation of states, and so on. Similarly, in the biodiesel component databank, it contains parameters for 461 organic compounds typically found in the biodiesel production process. And what are those components and corresponding parameters stored in this databank? These are the parameters. These are primarily the fatty acids. Those are used in the biodiesel production and processing. Another very important databank that appears in the latest versions of Aspen Plus is the biofeed. The biofeed databank contains parameters for 19 base biomass components, 13 intermediate and product components, and 530 biocomponents used as feeds to biomass conversion processes. And what are those components and parameters? The details are given on this page. These are the conventional components, those are stored in the biofluid databank. Since Aspen Plus version 14 has the capability to simulate biochemical processes as well as electrochemical processes, so the relevant databanks and corresponding unit operations are also introduced in this version. You can also notice a couple of other databanks. I will suggest you to spend some time and read the details information about the other databanks. So to add further components, either you can add the component ID. As you can notice here, while entering the component ID as butane, the Aspen Plus only retrieved the component that is normal butane. Whereas in the given example, we were asked to add the component normal butane as well as the isobutane. So to add the isobutane, either you can try whether ibutane is also present as a component in any of the databank. Yes, the isobutane ibutane was also added in the component databank either as the alternative name or the component name or the alias. You can notice these two components have the different case numbers. Similarly, you can add pentane. Like butane, it also retrieves the information of the normal pentane. You can try the same way pentane. Aspen Plus does not allow to enter the component ID that is more than 8 characters. Go to the find option. For example, we can enter a generic name as pentane. So you can search the pentane, either all the components that start with the pentane or contains the pentane term, or you can search exactly those components that matches this term pentane. So in order to shortlist the pentane, let's find the component information. There is only one component that is named as exactly pentane, and the pentane is listed as the alternative name, and it is normal pentane. If you search with a different criteria as all the components that contain the term pentane anywhere in the string, Aspen Plus retrieves more than 500 components that contain the term pentane, and this term may appear either in the alternative name or in the compound name. If you change the search criteria for all those components that start with the pentane, Aspen Plus retrieves 265 components. Either you can scroll down to search for isopentane from the available list. Alternatively, you can search iPentane. This search bar does not restrict the number of characters, so you can simply write any term you prefer. For the term I-pentane, Aspen Plus retrieved only two results. One is 2-methylbutane, the other one is the isopentane. As you can notice, both are exactly the same compounds with the same molecular weight, with the same case number, but they are stored in two different databanks. 2-methylbutane is stored in the APV 140 pure 40, and the isopentane is stored in APESV 140 AP equation of states. So to add the component, you can simply select it and add selected component to the list. As you can view in the list, a component ID is allocated and the component is entered. If you want to change the component ID as iPentane, you can change the name. It gives you option either to rename. Yes. If you want to delete any of the components, you can simply select it and delete it. If you want to delete all the selected components, you can select against the rows of any component and delete it. You can also view a couple of other options at the bottom. One of them is the electrolyte wizard. We will have a dedicated discussion in the next video. Another option is to add a user-defined component. You can also reorder the components in the list. For example, if you want to show carbon dioxide as the first component in the list, you can simply reorder, select the component, and move up. Otherwise, you can move it down. Another thing you should notice is the review tab that indicates review available pure component parameters. Currently, it's grayed out. We'll come back to this later on. To move to the next section, since required input information is incomplete, you can simply click the next button. Aspen Plus will automatically take you to the fields where input information is incomplete. Or you can scroll the navigation pane and see where the half red circle is there. Half red circle indicates the input information incomplete. So in the method specification section, you need to define a property method. As of now, I will select a random property method as Frank Robinson. Still, the status says required input incomplete. You can move the button next, and now the status has been changed automatically. Actually, Aspen Plus wanted us to review this section, and this section indicates the binary interaction parameters, and we will discuss it in the next video. But if you go back to the component specification option, now the review tab is active. Click it, and it will take you to the method section under pure component parameters. What are these pure component parameters? Go to the pure component parameters section. Here are all the parameters listed. You can also notice the type of the parameter. Most of them are temperature dependent. And one section review tab indicates scalar properties. You can notice in the scalar properties at the review tab, these are the thermophysical properties of the components. For the better fit, you can zoom out this page. As you can notice, there are several G-felt thermophysical properties entered in this section. For example, one of the property is the molecular weight, and the molecular weight of the nitrogen is listed as 28.0135. Similarly, the true boiling point of butane is listed as minus 0.49. So these are the scalar properties retrieved from the Aspen Plus Pure Databank. The other properties you can notice are the heat of formation, Gibbs energy of formation, charge on the component since all the components are neutral components, so no charge is mentioned on any of the components. You can also notice critical properties, eccentric factor, and so on. You have the option to change any of the number in this section. The other pure component parameters listed are the temperature dependent parameters. For example, the CPIGDP. What this term means, you can simply go to the tab and hover the cursor over the term CPIG-DP. CPIG-DP indicates coefficients for the differ ideal gas heat capacity equation. Similarly, another important parameter is the PLX-ANG, and this indicates coefficients for the extended end-time vapor pressure equation. As you can notice under the components, all the components are listed. The source of this information is also given, that is Databank Pure 40. The temperature pressure units are also mentioned, and most importantly, there are numerical values entered under the element 1 till 9. What are these numbers? These are the coefficients of the extended incline equation. You can also consult the help to view better information regarding extended incline equation. Here is the mathematical relationship for extended incline equation, and the coefficients C1 till C9 are listed in this equation. So the numerical values presented in the table are in fact the coefficients from the extended incline equation. So this equation can be used to calculate the liquid vapor pressure. There are also other equations to calculate the vapor pressure. For example, the Wagner vapor pressure equation, modified Wagner vapor pressure equation, and so on. Depending upon the thermodynamic method and corresponding thermophysical property model, Aspen Plus takes an appropriate choice to select one of these equations. And similarly, you can consult other pure component parameters as well. Another important subject of today's video is to define a component that is not available in the default database. We call it user-defined component. So you are asked to open a new case with a pharmaceutical template with metric units, add benzamide component. This component is available in the database. Then define a user-defined component called BZMG-UD with the structure formula as shown on the right. So the structure formula contains a benzene ring and amide group is added to the benzene ring. Actually, this is the structure formula of the benzamide. However, we will add this component as a user-defined component and base the component specification with the structure formula rather than importing from the pure component database. Then you are asked to estimate the missing properties of BZMD-UD user-defined component and compare its properties with the properties of the benzamide obtained from the database. So let's jump into the Aspen Plus interface. So go to the new tab, shift the units to metric. Here is the desired template. Pharmaceuticals with metric units. You can notice the unit set, default property method defined for this template. Open the selected template, write the name of the component benzamide. As you can notice, Aspen Plus does not allow to write the complete name of the benzamide because of the limitations of the character for component ID. So even if you hit enter, Aspen Plus is unable to fetch the component from its data bank because there is no component with this component ID available in the data bank. So go to the find option. Here write the complete name of the component, change the search criteria to equal to benzamide and find now. Here you can see Aspen Plus successfully retrieved the component information from the databank, and the databank is pure 40. You can also notice the molecular weight, boiling point, case number, and the compound class. Add the component to the selection. As you can notice, it has been added to the component list. Close this window and define the user-defined component. Just write the component ID. Aspen Plus is still unable to retrieve this component information because this component ID does not match to any of the criteria of the component information. Please notice that if you highlight the cell with the component ID and go to user defined section, it will automatically select the component ID. Otherwise, if you highlight another cell and then go to user defined, Aspen Plus will consider the component ID has not been defined so far. So highlight the component ID you have just defined, go to user defined option, keep the component type as the same conventional, click next button. Here you can define additional properties of the component if available, for example, the molecular weight of the component, normal boiling point, specific gravity, and ideal gas energy of formations. So far, we are not given with any of these properties. However, we are given with the structure formula of the component. You can either go to Draw Import Edit Structure tab, or you can click Define Molecule by its connectivity. In this window, you can notice three important tabs. One is the General tab where you can define molecule by its connectivity. Here you can define graphical structure. Also, you can define the chemical formula of the component. In the Structure and Functional Group tab, click Draw Import Edit button and it will open a new window of Molecule Editor. Here you can define the structure formula of the component. Just expand the window for the better view. You can notice three sections in the left side. First section is the bonds and the charges, where you can select the bond between the adjacent atoms, or you can define the charge on the individual atom. In the atom section, you can notice all elements from the periodic table are available. And the third section is the fragments, where some pre-built structure formulas are provided. So in the given case, we have the benzene ring and the amide group is attached to the benzene ring. To define this structure formula, we can take help from the predefined structure formula of the benzene. Just click it and drop it in the molecule editor window. Also, you can attach the amide group manually by choosing the bonds and the elements. The first element attached to the benzene ring is the carbon with the single bond. Just click it. It will automatically define the bond and the elements. Also, it will complete the valency of the attached carbon atom by attaching hydrogen atoms. Next is oxygen element attached to the carbon with the double bond. You can select the double bond and oxygen element and attach to the carbon atom. And the next is nitrogen attached to the carbon with a single bond. You can pick and drag and drop. So this is the amide group attached to the benzene ring. If you want to erase any of the bond or element, you can go to the option erase and remove the bond. Even you can remove the elements and the compounds. So let's again attach oxygen with the double bond to the carbon atom. Here we have completed the provided structure formula of the user defined component. To save this structure formula, go to the save option and you can save the component. Notice the extension of this file, it's .mol. Just save it and you can close this window. As you can notice, the structure formula of the user-defined component has been imported in this window. You can notice the General tab as well as the Formula tab. As of now, they are empty. But if you calculate the bonds and again have a look into the General tab, the compound has been defined by its molecules and connectivity. Even the bond type against each element pair has been defined. For example, in the benzene structure, carbon is attached to another carbon with a double bond. Then carbon is attached to the third carbon with a single bond. Third is attached to the fourth carbon with the double bond. Fourth is attached to the fifth with a single bond, then double bond, and then the single bond. That completes the benzene ring. And then the fourth carbon atom from the benzene ring is attached to another carbon atom in the amide group. Then the carbon is attached to the nitrogen and carbon is attached to the oxygen with a double bond. So this completes the chemical formula by its connectivity. Similarly, the complete chemical formula is given here, where the carbon, hydrogen, nitrogen, oxygen, along with the number of atoms attached in the structure formula are provided. Once defined, you can close this window. The status has been changed as structure form was opened. Go to the next option. In this tab, you can provide additional information to estimate the properties of the component. For example, the molar volume data, vapor pressure data, extended end-time vapor pressure coefficients, ideal gas heat capacity data, or ideal gas heat capacity polynomial coefficients. For example, in the ideal gas heat capacity polynomial coefficients, you can define the coefficients from 1 to 11, where it can determine the ideal gas heat capacity of the pure component. Since we are not provided with any of this information, we can estimate the properties of the component using its structure formula. To estimate the properties, either you can evaluate the properties using NIST Data Engine. If the component structure formula matches any of the component from the default databanks, it will fetch the information from the databank. Alternatively, you can estimate the properties using Aspen Property Estimation System. Although we know that the user-defined component is exactly the benzamide component that is available in the databanks, we prefer to estimate the property using Aspen Property Estimation System and compare the properties of the two components. So we have successfully defined the structure formula of the components. Now you can run the properties. As you can notice, the results are available. To view the results, you can go to the method section. Under the parameters pure components, these new tabs has appeared. The first tab is regarding the heat capacity coefficients, ideal gas, where the coefficients of heat capacity has been estimated. Here the source of these coefficients is the property constant estimation system rather than the data bank. Also, you can notice other tabs. Here you can notice the scalar properties that has been estimated by property constant estimation system. The molecular weight of the components, true boiling point, critical properties, energy of formations, and so on. All of these properties has been estimated entirely based on the structure formula of the component. To compare the properties of the two components, go to the component specification tab again, review the properties of the components. It will automatically take to the pure components review option. Here you can review the scalar properties of the benzamide components that is retrieved from the Aspen Plus data bank. To simultaneously compare the properties of the two components, go to the results option. Here you can notice the scalar properties of the two components compared head to head. You can notice couple of properties, the molecular weight of the two components, benzamide and the user-defined component, they are exactly the same. Similarly, eccentric factor, there is a slight difference between the critical pressure. You can notice that there is a significant difference between estimated true boiling point of the benzamide component and the user-defined component where the structure formula of the two components is exactly the same. Similarly, you can also notice other properties where some of the properties of the user-defined components are close to the databank components and some of the properties are massively different from the databank component. One of the possible way to rectify the difference is where you have the better information regarding user-defined components. For example, if you are aware of the true boiling point of the user-defined component that is 290 in the databank and 239 by the component estimation system, in order to replace this 239 by a better known value, you can go to pure components. Here are the properties of the user-defined component and you can replace this value. It will improve the property estimations of the user-defined component. Similarly, if you are better aware of any of the other scalar property of this component, you can change in this window. Besides scalar properties, you can also compare the temperature-dependent properties of the two components. Go to the pure component. In the temperature dependent tab, you can notice that there are a couple of properties available where you can view the parametric values. For example, the liquid thermal conductivity. Here you can notice the comparison of the property parameters. This is how you can define a user-defined component and estimate their properties and compare the properties of the user-defined components with the default databank components. If you prefer to further read about the user-defined components, go to the help button, search user defines. There is a separate section of user defined component wizard. Go to this section, expand the window. Here you can read about the user defined component wizard. This is a step-by-step guide about defining a user defined component. This is also the information regarding additional data to the user defined component for the better property estimations. You can also consult other resources. For further practice regarding defining a user-defined component, I propose following practice problem. Here you are asked to open a new case with a chemical with metric units. Add for alcohol In the component list, define another user-defined component called FFA-UD, and the structure formula of the user-defined component is given on the right. So you are asked to estimate the missing properties of FFA-UD user-defined component and compare following parameters of the two components. Molecular weight of the user-defined component with the molecular weight of propyl alcohol, and compare the coefficients of extended entrained vapor pressure equation. So today we learned about adding components, learned about different component databanks, learned how to view properties and parameters of the pure components, and learned how to define a user-defined component. In the next video, we will explore electrolyte wizard and learn about Henry components. Thank you.